right. Convert 4 plus 3i to polar form. So first thing you need to know is this guy right here is the a plus bi. What kind of form is this? Nope.
Rectangular. It is also 4.
All right, it is rectangular. All right. Now, it's also imaginary. So when you have rectangular, we used to do in Algebra 2, I hat, j hat. I hat, j hat is for real, okay? And then if we do a plus bi, that's for imaginary. All right, either way, it is in rectangular form, which means you can graph it on an xy axis. And this x-axis is the real axis, and the y-axis is the imaginary or the I-axis. So this is just like the coordinate point 4, 3. 4 plus 3i. And we're converting to polar form. So what is polar form? Polar form also has two forms. So back when we did I hat, j hat, we converted to polar form with the sled, where we did the radius and we did the angle. This is when you have I hat, j hat, and it's real, okay? But we have imaginary right now. And if it's imaginary, that's when you do our cosine, I sine, theta. So you do your Cysts, which is what we're pretty much doing right now. So we're pretty much doing a plus bi and Cysts. So I've got 4, 3 as my coordinate point. 1, 2, 3, 4, 1, 2, 3. So you want to make a little graph. Draw your triangle. Always connect to the origin and the x-axis. So this is a distance of 4, and this is a distance of 3. So what's my hypotenuse? Yeah, this is a 3, 4, 5 triangle. So now I want to convert to polar form. I need the radius, and I need the angle from the positive x-axis over to the hypotenuse. So my radius is a distance of 5. So I get 5. And then I write cosine I sine, or Cysts. And then I need the angle. So in order to find the angle inside the triangle right here, we always use what trig function? We use tangent, because that way if you messed up on Pythagorean theorem, you still, I guess you could use sine, but you should use tangent just in case. So tangent of that angle right there is equal to 3 over 4, because it's opposite over adjacent. And then we do inverse tangent on our calculator. Plug that in, and you get an angle of 36.870 degrees. All right. If you're in quadrant 2, remember you have to subtract from 180. Quadrant 3, you got to add 180. Quadrant 4, subtract from 360. Just a little reminder. So what if we're multiplying cosine I sines together? So I'm in polar form and I'm multiplying. What do I do with these outside numbers here? Yep, we multiply them. So I get 8. And what do I do with the angle measures here? We add them. Good. So 30 plus 90 is 120. This would be our final answer as long as we were supposed to be in, what form is this? Polar. Polar. So you guys, how do I remember it's in polar form? There's an angle. Polar, there's always an angle. Rectangular has to look like a coordinate point, like a plus bi or I hat, j hat. It's like a coordinate point, okay? So samesies here. Let's multiply and we'll just stay in polar form. So I'm going to multiply these 3 numbers all together, and we get 27. And I'm going to add my angles together, and we get 30 degrees. Well, that's great. All right, if it said convert back to rectangular, then you would just put it in cosine I sine form and evaluate it, okay? So use DeMoivre's theorem, used for complex expansion and finding complex roots. So we're going to find 3 Cysts 10 degrees to the third using DeMoivre's theorem. So this is the exact same thing as what we just wrote above, right? 3 Cysts 10 times 3 Cysts 10 times 3 Cysts 10 So it's 3 times 3 times 3. So if I use the little formula over here, this 3 is actually going to cube the radius. So I'm going to get 3 cubed. Then I do cosine I sine. And the 3 is actually going to multiply to the 10. Because why? We're adding the angles together. So it's 3 times 10. So we get 27 cosine I sine 30. All right, so what does the exponent do? It goes into the exponent of the radius, and it multiplies to the angle every time. Everybody get this little formula? Exponent here, multiply here. All right. Oh, wait, let's make sure we went all the way. Yeah, it didn't say which to go into. So let's find 1 plus I to the 13th using DeMoivre's theorem. So 1 plus I is what form? It is in rectangular. In order to use DeMoivre's theorem, you must be in polar. So step 1, convert this to polar. All right, so just start with, we have 1, comma 1. There's really a 1 in front of the I. That's just the coordinate point 1, 1. So I went over 1, up 1, put a point, and draw your little triangle. So over a distance of 1, up a distance of 1. Pythagorean theorem to get your radius, 1 squared plus 1 squared equals c squared. So we get the square root of 2 for our hypotenuse. So I'm going to rewrite this, and it's going to still be to the 13th power. So in order to be in polar form, the radius goes first. Polar form is r cosine I sine with your angle. So my radius is the square root of 2. And then I do cosine I sine, and I need this angle right here. Always use inverse tangent. Good. So I do inverse tangent of opposite over adjacent. Or, as most of you guys know, it's 45 degrees. You could use your calculator and it would tell you 45 degrees. Now we're going to use DeMoivre's theorem. Okay, so DeMoivre's theorem always says whatever the radius is, you're going to take it to that power. So the radius is the square root of 2. So we've got the square root of 2, and we're going to the 13th power. And then it multiplies, the number 13 multiplies to the 45. So I have 13 times 45. So 2 to the 13th power. Well, the square root is the same as the 1/2 power. So this would be to the 13 over 2. And I'm going to go ahead and multiply 13 times 45, and that's 585 degrees. Let's see, so 2 to the 13th power, how many times is 2 going to 13? 6 times. And then there's still another 1/2. That's the same thing right there. So 2 to the 6th is what? 64. Yeah, so I have 64, and I still have this root 2. This one's annoying. They're not usually like this weirdness, okay? And so that's lovely. And then I have cosine I sine 585. However, 585 is not from 0 to 360. So what I need to do in order to put it in true polar form is subtract 360. Those angles are the same angle. So I'm going to subtract 360, and I get 225. Evan, do you have a question? I thought you were raising your hand. Oh, you're getting excited. That's great. All right, now this one is super fun because we started in what form right here? Rectangular. What form do you think we should end in? Yeah, that would be nice. We should end in rectangular. Unless, you know, it tells you to leave it polar. So that means I would have to do 64 root 2 cosine 225 plus I sine 225. Yeah, this one does end up kind of nice. So 225, you guys, sorry, is about like all the way over here, right? And so it's right in the middle there. What coordinate point do we get? Yeah, that's the root 2 over 2 one. So I'm going negative. So that means the cosine, the x one, is negative square root of 2 over 2. And the sine one is also going down, so that's a negative root 2 over 2. And we usually put the I in the back there. And then I'm going to distribute this 64 root 2. So when you multiply these, you multiply top to top, bottom to bottom, and you get 64 root 4 over 2 with a negative there. Okay, then I'm going to multiply the top to the top and the bottom to the bottom. So I have a minus 64 root 4 over 2 I. What does the square root of 4 equal to? So these actually cancel, and these actually cancel, and I get negative 64 minus 64 I. What form is that? Rectangular. Okay. Find 3 cube roots of 8 cosine I sine 36. This means we're finding the cube root of 8 cosine I sine 36 degrees. So let's find a cube root. This would be the same thing as, so cube root is the same as what power? 1/3. So I'm finding 3 cube roots. 3 means we're actually going to get 3 answers. And I'm finding a cube root. That's what a cube root looks like, which is the same thing as the 1/3 power. So now I use DeMoivre's theorem, which says I'm going to take 8 to what power here? 8 to the 1/3 power. And then I'm going to multiply 1/3 times 36 for my angle. So what is 8 to the 1/3 power? It is 2. Cosine I sine, 1/3 of 36 is 12 degrees. Now, it said find 3 cube roots, right? We just found 1 solution. We need 2 more solutions. So what you want to do is you want to take 360 degrees, and you always divide by the index or the root. So notice my root was a 3. So I'm going to divide by 3. This gives me 120 degrees. This is what I'm going to add to this angle here. So I get 2 cosine I sine 132 degrees. Now I'm going to add 120 again because I need 3 total answers. So 2 cosine I sine 252 degrees. All right, what form did we start in? Polar. What form did we end in? Polar. Okay? All right, find the 2 square roots of 1 and give them in rectangular form. So 1 is the same as 1 plus 0i. What form are we in? Rectangular. So if I were to graph this, I'm going to go right here over to 1. So this is a distance of what? This is a distance of 1. Very good. So if I want to put this in polar form, my radius is 1. What is my angle measurement here? It is 0. Yep, I didn't move anywhere from the x-axis. All right, so I've got both forms here. I want to find 2 square roots. 2 meaning 2 answers. Square roots meaning a square root. Or it's the same thing as what power? 1/2. All right, so that means I do 1 to the 1/2 power. And I multiply the 1/2 times 0. So 1 to the 1/2 is the same as the square root of 1, which is 1. And 1/2 times 0 still gives me 0 degrees, right? But we have to find another solution. So I do 360, and this time I divide by what? 2, because I took a square root. My index here that you don't see is a 2. That gives me 180 degrees. So I add 180 to the previous answer, and I get that. Now, my 2 answers that I just found are in what form? Polar. And what does it say to do? Rectangular. So that means I have to go back to just what is cosine I sine. So it's 1 times cosine of 0 plus I sine of 0. And my other solution will be 1. I left a little space under there. Cosine of 180 degrees plus I sine of 180 degrees. Guess I should put little degree signs on all my degrees. All right, you guys, what's the cosine of 0 degrees? It is 1, right? It's the x part of the coordinate there. So I get 1. And what's the sine of 0 degrees? So 0 times I. That whole piece goes away. I get 1 times 1, which is 1. Okay, 180 degrees is over here. That would be this coordinate point. What is the cosine of 180? Negative 1. What's the sine of 180? It is 0. And I get 1 times negative 1, which is negative 1. Interestingly, what did this question actually say? Find 2 square roots of 1. What's the square root of 1? Plus or minus 1. Wasn't that great just for all? I mean, it's so great that we just know all this math to do it that way. I don't know. Probably you could. But this one is important. So apparently all the advanced kids miss this, so we have to talk about this one as well. Add this onto your examples. Find the 5/5 roots of I. So I need 5 solutions, and I'm finding the 5th roots of I in rectangular form. So, sorry, negative I. So negative I is the same as 0 minus I. So if you were to graph this, 0, this is on the real axes, and then this is on the imaginary axes. So what direction do I go for minus I? I go down 1, right? This would be like the point 0, negative 1, or negative I, right? So where people mess up when they're doing cosine I sine is on the distance. What is this distance right here? It is 1. Do we ever put negative 1 for a distance? No. Can you ever have a negative radius? No. All right. Anytime you're doing polar form, your R value in the front here should be positive. That's where everyone messed up. Otherwise, it reflects it and shoots it the other way, if you guys remember vectors. Okay. All right, and then we do our angle measurement, which we always start at the positive x-axis and go over. So what degree measure is this? 270 degrees. All right, it says to find 5th roots. So that means I'm finding the 5th root of this, or 1 cosine I sine 270 to the 1/5 power. So that means I'm going to do 1 to the 1/5, and I'm going to multiply 1/5 times 270. So if you're taking the 5th root of 1, it is still 1. And then 1/5 of 270 is 54 degrees. All right, but how many solutions do I have? 5. How do I find them all? 360 divided by 5, which is 72. And I'm going to add 72 4 more times because I already have one of them. So I'm going to add 72, and I get 1 cosine I sine 126. And I'm going to add 72 to that answer, 1 cosine I sine 198. Add 72 again, 270. And add 72 again, 342. How many solutions do I have? 5. All right. Luckily, oh no, not luckily. What form did we start in? I'm not doing all these, don't worry. Okay, but what would you do? You would convert all 5 of those back. However, can you do these using the unit circle? No, you cannot, because they're not like the 30s and the 45s and the 60s, so you'd have to use your calculator and plug them in, okay? I don't think you get very many like that, so I wouldn't get too stressed. No, I don't think there's a Cysts button on your calculator. All right, you guys, try. We got 2 whiteboards. Let's start on this one.